All right, guys, so I'm gonna jump back in and talk a little bit more about calorimetry. I am going to share the screen and pull up the table that we will use because I think it is helpful if I can find it. There it is. Okay, so I'm gonna scroll down here just a little bit. We've talked about what a calorimetry experiment is, but what I wanna do is look at the calorimetry table and explain a few things about it, okay? So this is a calorimetry table. And in any calorimetry experiment, there's going to be some information that you do know and other pieces of information that you don't know. So oftentimes what you're going to be given is a mass of a calorimeter, a specific heat of the calorimeter, which would be this one right here, your initial temperature of your liquid, and your initial temperature of your calorimeter. Those are just things you kind of need to know, not kind of, you do need to know to be able to do the experiment and actually calculate the data, right? And then you oftentimes will be given the final temperature. Now, if you're doing a calorimetry experiment live, then you're not going to know the final temperature until the experiment is over. And that's how you know your experiment is done, is when the temperature is unchanging. So you should know the specific heat of your liquid. If it's water, it's always going to be 4.184 because we're going to use joules, grams, degrees Celsius. And we should know the initial temperature of our object, okay? So these are pieces of information that we know. What I want you to see is that some of the information is the same. So for example, if you're given an initial temperature of water, then if the water is sitting in the calorimeter, the initial temperature of the calorimeter is the same. So these are both 23 degrees Celsius. You would know the initial temperature of the object. It's usually 100 degrees. It could be something else, but you're going to be given that, right? So then also, I want you to see that when there's certain pieces of data that are going to transfer from to more than one row of this table. So if the final temperature is of the object is, whatever it is, it's going to be this, the water is the same temperature and the calorimeter is the same temperature. So the data point for all three of these will always be the same in a calorimetry experiment. And clearly, whatever change happens to the water will happen to the calorimeter as well. Now the object is going to have a different change in temperature, but the temperature change between the calorimeter and the water will be the same. And then finally, we have three separate Qs here. But one of the things I want you to understand or want you to know is that if you take the energy of the water and the calorimeter, okay, those two together will equal the water change of the object, except this will have a positive value because it has absorbed the heat, and this will have a negative value because it has released the heat, okay? So those are, again, pieces of information that help understand just what happens in the experiment. All right, I'm gonna go ahead and get rid of my annotation tool. Okay, let's go ahead and walk through a problem, okay? I'm looking at problem number 14 from the review questions. Okay, and it says a calorimetry experiment is performed on a 112.1 gram sample of metal. It's heated to a temperature of 175 degrees Celsius and put in a calorimeter that contains 250 grams of water. If the water's temperature rises from 27.1 degrees Celsius to 31.7 degrees Celsius, what is the specific heat of the metal? Ignore the calorimeter. Okay, so one thing I meant to say earlier too is that, where is it? Oh, nope, I don't know where it went. Maybe it's down here. That's okay. Okay, so they're telling us that we can ignore the calorimeter. So what does that mean? It means this whole, oh, I know what it was. It means this whole top row. We don't care about any of the data in that. Now, sometimes they're going to ask you just to find information about the calorimeter. But for this one, all this, we don't care. None of it. We're not going to, we're going to ignore, we're going to assume, oops, that's not very good. We're going to assume that there was no impact of having the calorimeter there at all, okay? The other thing I was going to tell you is that if you can solve if you know there's 1, 2, 3, 4, 5, 6, right? If you know all but one piece of data in any given row, then you can solve for the missing piece of data, okay? So we're looking at the information we've been given, okay? And that from our problem, we were told that we have 250 grams of water. The object is 112 grams. We know we're using water, so we know that we have a specific heat of 4.184. We're trying to find the specific heat of the object. So this one here, we actually don't know to begin with. That's what we're solving for. We know the initial temperature of liquid was 27. We know the initial temperature of the object, far greater than 100 degrees Celsius. It was 175 degrees. And we are told that the water changed to 31.7 degrees. Okay, so how do we go about solving one of these problems? Well, you look, okay, so again, this, we don't know this. We can figure out the change in temperature. It's 31.7 minus 27.1, that's 4.6. Q equals mass times C times delta T. So when we multiply 250 times 4.184 times 4.6, we get 4,800 joules. Here's how this works. If this gained 4,800 joules, this lost 4,800 joules. So now I can fill in negative 4,800 joules for this, and then I can solve for my C, okay? And obviously there that would be if Q equals, oops, I'm not even gonna try to write it all out. C is gonna equal, MC delta T is gonna equal Q divided by M times delta T. Sorry for my using a trackpad. It's as good as it gets, okay? So that's my equation. So I would take my negative 4,800 joules and divide that by my mass, which is 112.1 grams, times my temperature change, which is negative 143.3 degrees Celsius, Celsius. And when I do that, I get a final answer of 0.30. Now, one of the things I want you to understand here is that when we're solving for this C here, this is going to have a negative value. Change in temperature is going to have a negative value. Obviously, these cancel each other out, and we end up with a positive value for our specific heat. So that is how, I'm going to erase here so we can scroll down. That is how a calorimetry problem works. Hopefully that makes sense. I'm going to stop this for now. And yeah, we're not going to walk through all of it. That's how it works though. And the next video is going to be about latent heat. So thanks for watching.